Hey guys, welcome back to the CI lab. Today we're going to study the structural isomers. We're going to look at their different types, and most importantly, we're going to learn how to identify them in the exam questions. So let's get started. So first of all, let's talk about the exam definition of isomers. These are the molecules that have the same chemical formula but different structural formula. Now, this might sound a little confusing, so let's look at these examples. Now, you can see that both of these two compounds have the same molecular formula of C4H10. And this tells us that both contain exactly 4 carbon atoms and 4 hydrogen atoms. But if you look at their structures, both of them are arranged differently. The first one has all of the 4 carbon atoms connected in one main chain. But if you look at the second one, the first 3 carbon atoms are in the main chain, and 1 carbon atom is coming off as a branch. So remember this simple idea: same atoms, same molecular formula, but a different arrangement of these atoms. That's what makes them the structural isomers. Furthermore, let's talk about the two main types of the structural isomers: the positional isomers and the chain isomers. Let's first talk about the position isomers. So you can see that the name itself contains a clue. This word position tells us that we have to change the position of something. And that thing can either be the functional group or this carbon-carbon double bond. Now here we have the example of butene, C4H8. And here you can see that in the structure 1, the double bond is between the carbon 1 and carbon 2. But then in the structure 2, the carbon double bond has come between the carbon 2 and the carbon 3. And now you can notice that the carbon chain has remained at its place. The thing that has moved is this carbon double bond. And that's exactly what the positional isomerism means. And another thing to note down here is that the position isomers is only applicable to the alkenes and alcohols. Okay, now let's talk about this thing. It's not an isomer. And to understand this, we first have to understand the nomenclature. So nomenclature is the system of rules which are used to give organic compounds a correct and unique name. So basically, nomenclature consists rules for naming the isomers, and you don't have to remember this definition, it's just here for the explanation. Let's first talk about the rule number 1. So the rule number 1 says that identify the longest continuous chain of the carbon atoms. The chain here means this chain. Chain is basically the main line which contains all the carbon and carbon atoms. And in the second rule, it's written that we have to number the carbon atoms in the largest chain or in the longest chain from the end that gives the functional group the lowest number. Okay, I'm going to show you how to do that. And the last rule says that we have to use that number to name the compound. Alright, now we've got the idea of all the rules for naming the isomers. Let's apply them to this example of butene. Here we have got the structure 1, and the first rule said that we have to identify the longest chain. And as you can see that there is no other chain present here, so this will be our longest chain. Now let's start numbering it from the end that gives us the functional group. Alright, you can see that both of these carbon atoms contain this double bond, so we have to start numbering from here. So let's first number it with 1, then we've got the 2, then we've got the 3, we've got the 4. Now you have to do the opposite. You have to start numbering from here: 1, 2, 3, and then 4. Now you have to notice here that which carbon atom with the functional group is getting the least number. You can see that this carbon atom is with the functional group and contains the least number 1. So we're going to use this number to name our isomer. And it's going to become like but 1 ene. It's just like you have to put the prefix at first, but, and it can either be pent and can either be eth, meth, anything. And then you just have to end it with ene, and in between comes the number that is with the carbon with the functional group. Alright, now let's name our structure 2. Now this is our longest chain, so we are going to number it. We're going to start numbering from here, 1, 2, 3, 4, and now we're going to do the opposite. We're going to start numbering from here, 1, 2, 3, and 4. Now notice that which carbon atom with the functional group is getting the least number. And you can see that both of these carbon atoms are getting the least number 2. So yes, we're going to use this 2 to name our isomer. And it's going to become but-2-ene. Alright, now let's name our third structure. Well, this is our longest chain. And we're going to start numbering from here, 1, 2, 3, 4. And then from here, 1, 2, 3, and then 4. And now you're going to notice that this is the carbon atom with the functional group, both of these. And here you can see that the least number here is 1, which is with this carbon atom. So we're going to write but-1-ene. Now you can notice that both of these structures have the same name. So read this note first. It says that if two structures have the same name, they represent the same compound and not different isomers. And that is why it was written here, not an isomer, because both of these structures were getting the same name. No different isomers can have the same name, and therefore we're not going to consider it as an isomer. So we only have 2 isomers here, which is but-1-ene and but-2-ene, and this is not our isomer. Alright, so now here we have example of propanol C3H7OH, and here we have to draw all the existing isomers of the propanol. So let's start doing it. Firstly, let's just draw the normal structure of the propanol, which is like this. Let's first draw the 3 carbon atoms, 1, 2, and 3, and then we have to join 3 of these together with a single bond. Alright, and now we have to put our hydroxyl group with our very last carbon atom like this. And then we have to complete the 4 bonds of each carbon atom like this. Alright, and then we're going to put H atom along with each line. Like this. Alright, now let's name them together. So it was said that we have to identify the longest chain here. And you can see that this is our longest chain. And we're going to start numbering it like this. 1, 2, 3. And then we're going to do the opposite. 1, 2, 3. And now you can see that this carbon atom contains the hydroxyl group, which is our functional group. And therefore, we're going to take the least number here as 1. So therefore, we're going to use 1 as our number to name the isomer like this, which is going to become like propan 1/O. So this is our first isomer. Now let's draw the structure 2, which is going to be different from this one. So we're going to draw it like this. Firstly, we're just going to draw the normal 3 carbon atoms, 1, 2, 3, and we're going to join 3 of these together with a single bond. Now we're going to put this hydroxyl group to the second carbon atom like this. We're going to join it with our second carbon atom like this. And now you can see that the position of only the functional group has changed. The chain has remained at its place. Now let's complete the 4 bonds of each carbon atom. 1, 2, 3, 1, 1, 2, and 3. And let's put H atom along with each line. 2, 3, 4, 5, 6, and then the last 7. Now let's name it together. So we have to identify the longest chain, which is this one. And then we're going to start numbering it like this. 1, 2, 3. And we're going to do the opposite. 1, 2, 3. Now, as you can see that this carbon atom is with the functional group. And the least number that it's getting is the 2. So we're going to use this 2 to name our isomer like this. Propan/2/O. And this is our second isomer. Now let's draw the structure 3. So we're going to just draw the 3 carbon atoms. 1, 2, 3, and we're going to join 3 of these together with a single bond. Then we're going to join the hydroxyl group with this very last carbon atom, like this. And now let's complete the 4 bonds of each carbon atom. 1, 2, 3. And then we're going to put H atom along with each line. 1, 2, 3, 4, 5, and then 6, and last 7. Now let's start naming together. The longest chain is this one. We're going to start numbering from here. 1, 2, 3. And we're going to do the opposite. 1, 2, 3. Now as you can see that this carbon atom is with the functional group. And the least number that it's getting is 1. So we are going to use 1 to name our isomer. So it's going to become propan 1O. Now you're going to notice something, that both of these are getting the same name, which means that both of these are representing the same compound, and therefore they cannot be considered the different isomers. So we only have 2 isomers for propanol, which is propan 1O and propan 2O, and this cannot be considered as an isomer. Alright, so now let's talk about the second type of the structural isomer, which is the chain isomers, and it deals with the branches. So now I'm going to tell you a trick that helps you to identify that which one is a single chain and which contains branches. So see this line. You can see that it is straight, and I only have one way of moving ahead. This is actually a single straight path, which means that it is a single straight chain. But you can see that here we have a little bit turned or cornered chain. But the thing is that this is still a single chain because I am moving further and I only have one way of moving ahead. I cannot go through this way or this way. I just only have this way of moving ahead. And the same thing is happening here. I only have one way of moving ahead. So this is a single chain with 4 carbon atoms. There is no branches in this chain. And the same thing is happening here. I am moving from here and I only have one way to move ahead through this path. I cannot move here or I cannot move there. So this means that there are no branches in this chain. This is a single chain with 4 carbon atoms. But now if you see this thing, I am moving further and I see that I have 2 ways of moving ahead. I can either go through this path or this path, which means that both of these are branches. Which means that in this whole structure, there are actually 2 chains. Let me show you. This one is a single chain, and this one is a single chain. So the chain with the 4 carbon atom is actually the longest chain, and this one with the 2 carbon atom is the smallest chain. Now let's have a look at our example of butane. The question is saying us to draw all the possible chain isomers of butane. So right here we have only 2 chain isomers. The first structure is of the normal butane with a single straight chain. But the second structure is of the rearranged form in which we have created a branch. And it is called the 2-methylpropane. Now we cannot create the 4th or the 5th isomer because always whenever we form the chain isomer, we have to rearrange our chain of carbon atoms. So there was only one possible way of creating a branch. If we would have joined our last carbon atom with either the 3rd carbon atom or the 1st one, we could not have created a branch. So therefore, these were only the 2 possible chain isomers of butane. Now let's understand how to name the chain isomers. And it is a little bit different from the position isomers. So right here, I'm going to draw a few different structures, and we're going to see that how we name these different structures so you're able to practice easily. So let's get started. Here I'm drawing a carbon atom chain with 4 carbon atoms, and I have created a branch here by joining a carbon atom with our 2nd carbon atom. Now you can see that we have 2 chains right here. And according to the rule from the nomenclature system, we have to identify the longest chain. So the longest chain is the chain with the most number of carbon atom, and you can see that this will be our longest chain. So we're going to number it like this. 1, 2, 3, and 4. And now we're going to do the opposite. 1, 2, 3, and 4. Now, at the first place, we're always going to put the number that is with the carbon atom containing the functional group. And you know that there is no functional group right here, so we're talking about the branch. So we are talking about the carbon atom that is containing the branch. So we always have to take the least number. So here we're going to take 2, and I'm going to put it like this. And now I'm going to put a hyphen, and I'm going to write methyl here. And we always have to write methyl if ever we have a branch containing a single carbon atom, because this represents methyl group, therefore we have written methyl here. Now at the third place comes the parent name of our longest chain. So you can see that our longest chain contains 4 number of carbon atoms, therefore it will be named as butane. So the name of this structure is 2-methylbutane. Now let's look at our second structure. So you can see that I have created 2 branches right here. The first rule always says that we have to identify the longest chain. So the longest chain right here is this one. So we're going to number it like this: 1, 2, 3, and 4. And now we're going to do the opposite: 1, 2, 3, and 4. Now, both of these 2 carbon atoms are with the branch, so we are going to use their number to represent the name of our isomer. So we are going to take the least number from here and least number from here. 2 is already taken from here, so we're going to take the 3 from this one, and I'm going to write like this: 2, 3. Now, at this place is going to come dimethyl. You know that methyl represents this single carbon atom in the branch, but the di right here is for these 2 carbon atoms that are in the branch, and therefore we are going to write dimethyl. Now the same thing, at their last place comes the parent name of our longest chain, which is butane, because there are 4 carbon atoms present there. So the name of this structure is going to be 2,3-dimethylbutane. So here I've got some points that are going to summarize the whole video for you. Let's start with the positional isomers. The first point is saying that they have the same molecular formula. It means that both isomers are going to contain the same number and type of the atoms, and they're going to have the same functional group, which means that in the example of alcohol, all the isomers are going to have the same functional group of OH. And then they have the same carbon chain. It means that there is no change in the arrangement of carbon atom, but the thing that is changing the position is the functional group or the double bond. And here I've got an easy trick for you that says that in the positional isomers, there is the same structure, but something has moved its position. And now in the example, the isomers are in their condensed structural form. And yes, you can use a bracket to highlight the group that is changing its position. Now let's talk about the chain isomers. So the first and the second point is similar to the positional isomers. The third point actually differs the chain isomers from the positional isomers. It says that the carbon atoms are connected in a different arrangement. So yes, this means that the carbon atom itself is changing its position to form a new branch. And the fourth point is saying that one may be straight chain while another is branched. This means that in the example of butane, so the first isomer has a straight chain, which is butane, but then the second isomer will have a branch, not a straight chain. So the easy trick right here says that the carbon chain itself changes its position. Now right here the example is same. The isomers are in their condensed structural form, and yes, you can use a bracket to identify or highlight the group that is changing its position. So this was all for today. I hope you liked my video and understood the concept. Don't forget to hit the bell icon and subscribe to my channel. Let's meet in another video.